This presentation is on the investigation of the effect of water activity on cardboard versus plastic packaging of raisins by
April Ball,
Ariana Bruyette-Spraker,
Natalie,
Admaja.
So first, we need to discuss that water activity is the unbound free water, vapor, or humidity produced in a sealed environment. This is really important for shelf life because it reduces microbial and bacterial growth, prevents spoilage, increases shelf life, and shelf stability. Proper packaging is really important for providing the ability to retain the product's texture, to manage the moisture and migration, prevention of caking and/or clumping. Studies from Buendia Morena and Fasoyiro support the theory that the cardboard container is superior in preserving the shelf life of food and also decreasing microbial spoilage. The gap in the study says that the previous studies lack comparison between packaging types. So the goal in this exercise is to determine the effect of water activity on packaging types, plastic versus cardboard. And then in this, we're testing SunMaid raisins in both plastic and cardboard packaging.
For methods and materials, we tested 2 boxes of 12-ounce raisins from cardboard packaging, and we tested 6 raisins from 1 box per trail. And then we analyzed 2 boxes of 32-ounce raisins from plastic packaging, and the same we did we analyzed 6 raisins from 1 box per trial. And then we used rotoronic hygroscope to measure the water activity. For the sample preparation and handling, 2 trials were conducted in this experiment, and making the total sample size to 24. We tested 12 samples for each packaging type, meaning 6 samples for each group. And we ensured to maintain the proper room temperature, and the samples were drawn randomly from the packages. So as for the methods, continue. So the effect of water activity levels on different packaging were tested here. We used SunMaid raisins to analyze the water activity levels. So the room temperature was maintained around 25 degrees centigrade. So we avoided heat sources near the equipment, near the testing. So we use the rotoronic hygroscope that has a probe which is connected to the computer via USB. So the samples were placed in a small cup, and a lid was closed to avoid any moisture absorption. The samples are filled up to the mark, and they were placed in the holder. Then the probe was placed above the sample cup. H4W software was used, and AW quick mode was selected to analyze the water activity of these samples. So with the quick mode, it took around 4 to 6 minutes for samples to reach the equilibrium. So these sample details were properly inputted to generate the report, which were then saved into the computer as a PDF file. So the process was repeated for the 2 trials, and the generated data reports were saved as a PDF file for further analysis.
So here's are the data that we collected from the experiment. The 2 highlighted data, sample 1 from the first trial for plastic, and sample 5 from the first trial for cardboard, and were eliminated at 95% confidence because they exceeded the critical value of 0.5624, giving a value of 0.584 and 0.5896 respectively, which means that they were considered as outliers and would not be included to calculate for the mean standard deviation, coefficient of variation, and t-test. So after all the math were done for the mean, standard deviation, coefficient of variation, and t-test, all numbers were rounded to 4 significant figures shown in this 2 table over here. It gave a mean of 0.6163 for water activity of raisin from the plastic packaging and a mean of 0.5608 for the cardboard packaging. From this graph here, we can also see that in general, a plastic packaged raisin has a higher water activity for all the trials when comparing to the cardbox packaged. The standard deviation of the water activity of the raisin from the plastic packaging was 0.0168 and 0.02598 for the cardboard packaging, which indicated that the spread of the data is relatively close together since all data fall within the 1 standard deviation range and would be considered as having a low variability. For coefficient of variation of the water activity of the raisin from the plastic packaging, 2.724 was obtained and 4.633 was obtained for the cardboard packaging. Both of them were less than 5, meaning that our measurements are precise and can be easily reproduced with similar results. And then two t-tests were performed, one for water activity and one for the room temperature. The p-value of the water activity was less than 0.05, which means that it is statistically highly significant, having meaning that it doesn't really have much error can be done. Meanwhile, the temperature of the raisin was not significant because it has a p-value larger than 0.05, which also means that the temperature doesn't play a role towards the water activity of the raisin.
All right, and then when comparing the 2 packagings, the cardboard had a water activity of 0.5608, and you can see that this is similar to the water activity of honey, chocolate, and rice. And those foods are all very, have a very long shelf life and very low rates of microbial spoilage. They can last years and be good. And then a water activity of 0.4 to 0.6 has no microbial growth, but is more susceptible to lipid oxidation. The coefficient of variation for cardboard was 4.633, which shows precision. For plastic, the water activity was 0.6163, which is similar to that of dried fruit and beef jerky. These foods last longer, but the maximum amount of time it can last is about 2 years. And this range, 0.6 to 0.9, does allow bacteria, yeast, and mold to grow, which is why the plastic container proved to be more susceptible to microbial spoilage. The coefficient of variation for the plastic container was 2.724, which also showed precision. And as mentioned before, the water activity p-value was less than 0.001, and that is highly significant. The p-value for temperature was 0.2530, which is not statistically significant, so it did not have an impact on the raisin water activity or microbial spoilage. Overall, the cardboard container was superior because it had a lower mean water activity, lower moisture content, less microbial spoilage, and a much higher shelf life. And then our study coincided with the studies of Buendia Morena and Faso Yiro. A few errors that we would like to correct next time are starting with technological errors. It's possible that the Retronic hygrometer was not plugged in correctly or set up correctly, or the HW4 software was working incorrectly or maybe on an improper setting. For environmental errors, it could have been humid, which caused the raisins to absorb moisture when being transferred from the container into the hygrometer. Or the most prevalent source of error is human error, and that can come from incorrect measuring or multiple people measuring out samples, because that would cause a lot of variability and not a lot of consistency.
So in conclusion, the Rotronic hygrometer was used to test the water activity or the equilibrium relative humidity inside of each packaging, since the risk of microbial growth and water migration increases when there's too much water in a product. So the results showed that the higher water activity was definitely with the plastic packaging. Both styles of packaging stayed within safe water activity ranges with no microbial growth reported. But more research is needed to come up with more ways to promote shelf life without any microbial growth whatsoever. Alternative packaging in the future may be needed to prevent microbial spoilage.